Our next presenter is Derrick Bommarito. I had the pleasure of working with Derrick for a year, producing online LabVIEW live presentations, and most of the time that we talk, I just graciously nod and I pretend like I understand it as much as he does. All right, all right. So here's Derrick.
All right. Good morning. I think we're live. Yeah. Mic sounds good. You can't hear yourself at all behind here. It's awesome. I'm Derrick. Right now, at this moment, I work at NI. I'm a senior technical support engineer. As of 2 Octobers ago, I worked for a couple of system integrators and an oil and gas company before that. Started using LabVIEW in 2011. I have a computer science degree. And I like making stuff in LabVIEW. So the title of this presentation, Summer of LabVIEW, actually belongs to Darren Nattinger. He came to me with a request to help him out with a project he wanted to run internal to NI. And I said, I have a whole bunch of ideas. So I wrote a web server in G. Web services are great if you just need simple data exchange, but I wanted extendable authentication flows. I wanted just reroutable behavior and didn't want to fit that into web services. So short history about me. I have a whole bunch of open source libraries that I published to VIPM under the moniker Illuminated G. And I already had a handful of streaming TCP libraries available, which we'll get back to their importance. So I do robotics projects, and I wanted to use WebSockets to run this guy. So this has a Raspberry Pi in there running the Links toolkit, running a WebSocket server, so I can do stuff with it over the web. So there is the Media Mongrels WebSocket implementation that already exists. There's a couple things I wanted to add to it. I had actually already had a WebSocket implementation from years ago, so I decided to rewrite it with the same abstraction that the TCP code was written with. With WebSocket, you have to do an HTTP handshake first. So of course that meant, as per my Scope Creeper Extraordinaire title that I put on the opening slide, I wanted a reusable library for HTTP parsing. Once I had the HTTP parsing, all I had to do was plug it on top of my TCP code. Now I've got a web server that I can just keep adding features to. And then after Darren came to me with the internal training idea, I said, I have an idea, let's use this web server. I now still have no robotics projects completed. So DNAT came to me and wanted to run a programming challenge project this year for sales and support in NI, and asked if I'd be interested in making a web portal for people to get the starting files from, see their scores, upload their entries, and run automated scoring and all of that. And I said, absolutely. I've got just the thing I've been working on. So he called it Summer of LabVIEW. Like I said, it's where you can go to get the files for the challenges. The first challenge was Wordle. We're doing a maze right now this month, and next month will be, so those are the 3 teaser pictures. Is anybody familiar with past LabVIEW challenges in the community? What that third one might mean. So we had Wordle, Maze Solver, Square Battle. So we'll be doing Square Battle for August. But the whole idea is there's just this one website that they can do to get all the challenge stuff and submit their entries. So the web server is built up on a couple layers of libraries. So if you needed just HTTP parsing, you could use just the HTTP utils package, which is already on VIPM. And there's a handful of things here that it uses. Also, apologies, there's a lot to cover, so I'm gonna be going really fast. Sam did offer his co-working space, so if anybody did want more detailed look at any of this, feel free to hit me up and we can look at it later. So it is a full web server. It does HTTPS, it has caching that kind of works, but I'm still figuring out how to set some of that right to make sure browsers do actually ask for new versions of files. It's got sessions. So if you're familiar with web services, the old app web server-based web services provided sessions. The NI web server-based ones don't anymore. And they can be really useful for larger web applications. It's got an authentication framework. It does form handling. It's got CSRF tooling for cross-site scripting mitigations. So as Brian mentioned, OWASP, spent a lot of time on OWASP.net, looking up all the web security stuff. It does file serving with streaming, so it doesn't load everything into memory all at once. It'll do 10K chunks, excuse me. It does 10K chunks just to be more efficient with memory. And it kind of does a little bit of a different model of code reuse. So some future ideas to make it more efficient. You can basically just wrap the processing loop in a loop and pay attention to the connection keep alive header that gets sent. Implement an API for how we route requests. Just to make that a little bit easier for people that don't know regular expressions that much, and some other optimization and future ideas. So this is the high-level server design. So it's got a processing flow, and each one of the blue shapes is a pluggable step, an extensible step that's represented by an interface. So this does use interfaces quite a bit, so I got to raise my hand a lot during Alan's presentation. So there is everything from, we get the connection, maybe you want to filter on IP addresses. That's not really secure, so a lot of our authentication stuff happens after the request gets parsed. But there's this predefined set of steps where you can plug different behaviors in at different points. So instead of having one big handler code for each URL request, you can split it up into different places. And like any good programmer, I stole/borrowed a lot of ideas from Symfony PHP's event flow. So there are two main components that get used in here. And these are represented as interfaces. So there's services and handlers. Services are components meant to be reused throughout an entire request flow, and handlers are what handle each step. So this is the Summer of LabVIEW application. There is the main process up in the top left, which then uses the HTTP server implementation, which itself creates two different processes, one for the insecure TCP, which basically just redirects to the secure. So if you make an initial request on port 80, it'll redirect you to the HTTPS port. And then from there, there's a secure server that does its request processing. And the whole idea of this is I wanted to run automated scoring of the entries. So we've got a loop that manages a couple of score workers that then use ActiveX to hook into a development environment and run the challenges. So that is the very high level view. Let's get a demo and see what it actually looks like to write an application with it. So this is a copy of it that I have running locally on my computer here. So all of the front end stuff is written in GWeb, uses JavaScript extensively to augment the behavior and get some of the more dynamic elements displayed. But we have a leaderboard for whatever the current challenges we're running. They've got links to all of our internal portal pages about the challenge. I'm already logged in, let me log out. So depending on if you're logged in or logged out, it changes some of what's displayed. So it does have a registration page. You could create an account that we then track your entries against. I've already got one, so I'm just gonna log in. And once you log in, you'll see the login and sign up links are gone. It greets you based on the name you signed up with. I logged in with somebody with admin credentials, so I have access to the admin page. This lets me see what entries have been submitted, which ones are currently being scored, and then the previous listings of what's been run. So this would be the page that Darren and I use to check to see if there are new entries that need to be run. If you're a participant, you can go to the challenges page, where you'd be able to download the files for the challenge. So Wordle had a project template that you can make a copy of and build your code into. Maze has a regular project template that they get started with, and we're still working on Square Battle. But you could go to a challenge. Participants can see their scores for their entries they've submitted. You can also use this to submit an entry. So I'm gonna go ahead and do that. Actually borrowed one of our participants' entries that runs really fast. So the projects that we created had a build spec that generates an LLB, and then you can go ahead and upload it, and it'll tell you that, okay, it's been submitted, here's that ISO 8601 formatted timestamp, because I didn't do any of the localization in this. But it's not run yet. It's waiting to be set to be scored. So an admin like Darren or I can go in and see it show up in the list, go ahead and approve it. If it doesn't run too fast, we should see it show up in the running list. This is also the score that it spawned in the background, although it popped up in front. But we can see that now this is using up a scorer slot. So Brian mentioned you can extend using JavaScript and tweak some of the behavior of things. So I use these data grids. They're mostly nice. They give you some things like where you can sort by scores, group things, group by users. So whatever your columns are, you can sort by them. But like most LabVIEW things, they're either controls or indicators. And I didn't want everything to be interactable. So I wrote some JavaScript code that finds a specific data grid, and I've got this approved column. I turn off the read-only attribute on it, and so now I can mark this as an indicator, but somebody can't go in and type in new values for any of the fields. So that's just an example of some of the customization you can do in GWeb. But there we go. So it ran. We could see that it's successfully completed. I've got this score based on the words that were chosen for that run. If we go to the leaderboards at the home page, oh, the challenge ended, so it's not showing the score anymore. If I go to see my own scores, I'll see it there. So here we can see that score, that this is what the user would be able to see. If there was an error generated while it was running it, we would display that here, or any other information that they would get about their scoring. So that's what the application is and what it does. This is all pretty much dynamically managed with SQLite database. Here is the actual LabVIEW application that was running in the background. One of the features it has is this trace logging. So for each request that gets made, you can see the URL that was requested, what the return status was, what the class type was of the response, because everything is overridable. This whole thing was written with extensibility in mind. And for each of, if you remember that process flow chart, there's a whole bunch of steps that can be run, that they're each intended to be very, very short. We can see here that a lot of these are running in 1 millisecond, 2 milliseconds, half of a millisecond. So you can track the timing, see where your performance hits are, and work on optimizing that way. But the idea is it's a whole bunch of really small steps being run instead of one big step. And then it tracks all of it for you. And I can see, I've got this set up to look at the last 20 requests that get made. This application, I did add in some custom error handling. Part of this application not built into the server, but no errors have been generated. And then in this application, we can change what the active challenge is. So if I change that and go back to the home page, we should see it's going to show me a list of the maze leaderboard. I don't have any entries on this locally, so there are none here, but everything is run from that LabVIEW application. So let's go ahead and close this down and look at some of the code. And at this point, feel free to stop me, ask any questions. I'm going to be primarily looking at this from the viewpoint of the application using the web server, because that's what everybody cares about. How much effort does it take to use it? But if you do have any questions, let me know. So top level of the application, doing some of the standard startup stuff, making sure the splash UI gets hidden, initializing the server, running the server if there were no initialization errors, and cleaning everything up, because good programmers clean up the messes they make. So initializing all the different parts of the Summer of LabVIEW application. Got a separate config class wrapper. We've got initializing the databases. We'll take a look at how I accomplish that in a little bit. Scoring IPC, so all of the mechanisms that get implemented to talk to the scoring loops. Error inter-process communication, the actual HTTP server, and then launching the scoring manager loop. So for this application, I used the SQLite wrapper that's available on VIPM. Shout out to JDP, really awesome library. And I wrap it in a single element queue just to get a little bit of by reference behavior with it, but not actually using a reference mechanism. And then this gives me the capability of my other database classes can pull out, can lock the DB by pulling it out of the queue, do their database operation they need to do, put it back in so other requests can access it. And then most of these other ones just make sure the table exists in the SQLite database. So here we can see it unlocks, pulls the database instance out, does the database stuff, and then can put it back in. But the main thing is this is what it looks like to initialize a server instance for this application. So in the config, I'm storing whether or not we want to run the HTTPS portion of the server. Otherwise, you can run just the insecure copy, but everything is exposed through declarative configuration here. Setting up HTTPS is as simple as pointing the certificate files at it and telling it what port you want to use and setting the Boolean to true. We'll take a look a little bit, but there are a couple of built-in mechanisms that use the same exact mechanism that you can extend the server behavior with. So we're configuring how sessions get stored, which is just local on disk. There's a file serving controller. So if you just want to serve a folder, if you want to serve files statically from a folder on disk, one of those exists out of the box. And this is how the server basically works, is you compose behavior from things that have inherited from these interfaces, and you just register with them in the server to get that functionality. I've currently got caching turned off because I'm still having some troubles with it. And configuring authentication, registering our custom services, and registering the step handlers. So authentication, enabling authentication looks really simple. It's not too terrible. There's a couple of things you need to provide. Obviously, we need to work on the server instance, so I'm pulling that out of my application class, as well as some user provider. So this is going to be the class instance that, given some user identifier, gives back the user instance. So I've got an actual class that represents user entities, and it goes in the SQL database based on the email address and pulls that user out. And then there is an authentication provider, which will, given a page request is it an authentication request? If it is, actually run the authentication code, and then it can have success and failure effects and other management of the user. take a closer look at that in a minute. So services, these are the things that are accessible. I want to be accessible in any step in a request processing flow. So for this application, it's just the databases. So we make these accessible, and you can pull these out very easily during a request. And then this is the bulk of how the work gets done in this. So each one of these is a different top-level request handler. So if you're trying to do a submission to the register endpoint, or trying to get a CSRF token, doing anything with the user API, getting a list of challenges, each one of those requests is represented here. Some of them, we're initializing some configuration. So that they'll have some state that they need while they're running. But most of the time, they're pretty dumb. They just work on the request that came in. So we can just use the default class types. So this will probably be interesting to Brian. This is how I accomplished my authentication. So this is a concrete implementation that's inheriting from an authentication provider interface. And it's got a couple of VIs to override to one. So the code shown here on the right is deciding whether or not we need to invoke authentication flow based on the requests that came in. So we're just checking from the parsed request, what was its URI path. So if it's a path to /login, and it's post, so it's got the user data attached to the body of the HTML of the HTTP request, we can return that, yes, you should run the authentication code. So if that returns true, then this code gets invoked. So the idea is with authentication, it's going to be pretty specific to each application you write, or maybe whatever your backend systems look like. You could integrate with LDAP, Active Directory, OAuth, whatever you needed to do. So you would implement that logic in here. So we've got the request where we're pulling the HTTP body out, converting it from the JSON into our request data, doing the CSRF check, using the user provider to get a user by its identity, which in this case is an email address, doing password encoding, so we're not storing plain text passwords. We actually run them through a couple of iterations of hashing. And eventually, if everything succeeds, we get a user instance that is then accessible throughout the rest of the request flow. If it succeeds, we can update some stuff in the session. So we can say what is, we got a couple of special keys that you could use or the rest of the server application uses, generate the response to redirect back to the home page on a successful login. And similarly, we can do different things for if it fails. Yeah, so that's how I did authentication, is in the server. 25. So there is, this abstract interface class that says support authentication. You just need to provide a concrete implementation that provides these this functionality. And there's more to it than that, but that's the high-level view. So that is an example of the server initialization for running it. Here's my main UI of the application. This is what it looks like to get the trace log. So I've just got a Boolean button, an event. From the server instance, I can just get the trace logs from them, reformat them for this table, and view that table of trace logs. And that is pretty much the interesting thing from the main UI. the whole other point of this application was to, where do I run the actual scoring loop? So we've got this loop running, which manages some scoring instances. So we set up a couple of scores, and then based on the challenge ID, it'll look for an executable in a certain folder on disk. It'll run that executable, which is past the path to the submission, and then we'll launch the actual scoring code in the development environment using the ActiveX interface, so that we didn't have to have any complicated build specs or anything like that. So based on when somebody approves a submission, the handler for that request will fire off an event that says, you know, here's the submission that we want to score. So it passes it in this loop. It runs a score asynchronously, and then waits for the results to come back, and a couple of other things happening in the background. So what does a typical request look like? So one of the main ways, actually before we look at the request handling code, one of the built-in ways for these different handlers to identify themselves for a specific URL request is with regular expression matching. So this is where that comment came for the URL pattern API is you don't need to know this. You can build up your path matching bit by bit and have named pieces. We are using submatching here, so you can use parts of the URL path as variables in the request that you can access later on. And then here, this is going to show a couple of things. So there's a data wrapper called the processing class that has all the things like the parsed request, the response that's been generated. It's got this container class, which uses maps under the hood. And some interfaces for pulling the services and variables in and out. But if we want to do things with security, like check for security roles and permissions, you get the security instance by pulling it out of this container by, I want a security instance, and it gives you the one that's been plugged in. Same thing if we need, this is the handler for getting the list of challenges. So we want the challenge DB instance and pull that out. Here at the bottom is an example of checking to see if the currently logged in user has the admin role. You can give a label to it if you want for logging and the error that would get generated. We don't care about the error on this. We just want to know if they are an admin or not. And then using our challenge DB, there's two cases here. This same handler will, if they're asking for a specific challenge for the more detailed information or just the list of all the challenges, it'll return a single element array or all of the challenges. And then we can filter them out to make sure they're not seeing challenges before they've started. Build up our data type that we can use we've got a similar data type in the GWeb application, converting it to JSON, plugging that in as the response to ultimately get sent back to the browser. So submit. So here's an example of some of the form processing capabilities. So when I uploaded that LLB, this would be the code that would get invoked. And this one gets invoked because the request gets made to /submit/ a number. So that would be the challenge ID that exists in the SQLite database. So right now, because the submatch would be in the submatch array index 1, we can pull that ID out knowing that this code is meant to work off of that regular expression, convert that to the numeric and look up that challenge. And then we can check to make sure that the CSRF token exists. If you're not sure what CSRF is, it's just It's a mechanism for protecting against forged requests from malicious websites, and pulling out the file that was uploaded, which we can get the path for it, and then we do things like move it to a known location. Let's not look at the error, let's look at when it works. So doing some file renaming, moving it around, creating an entry in the database for that submission, and then sending a success response back to the client again. Basically, once it exists in the database, that's when it shows up for Darren and I to see it. And that is all the very quick tour of the Summer of LabVIEW website, or at least the constituent parts. Any questions so far?
So are you taking the file that somebody would upload like on their laptop and then transferring it over into a known file location somewhere on the server that you have access to later?
Yeah, so the way file uploads work in web servers is it gets sent as part of the HTTP request body, and then the server parses that out. As it's parsing it out, it's saving it to a temporary location, and then when we're actually processing that, so this is where, you know, as part of the request parsing step, it would generate this form field instance which stores the path of the temporary location, and then assuming everything's successful, it's a valid challenge, all the CSRF mitigations and everything like that are good to go. That's when I, the LabVIEW, we move it to a submissions folder. So this is the handler class instance here, submit. That was one of the ones that we had a configuration for what folder we want to store, we want to upload submissions to. Makes a folder for each challenge. ID gets its own folder, and then the submission itself gets a folder as well. We rename it, make sure it's renamed LLB with the submission ID, and then that's when we do the copy, as long as all the folders were created successfully and everything else happened correctly. Okay, so let's take I've got some time. Let's take a little bit of a deeper dive on the server itself. So actually, here's the GitHub page for it. All of the stuff pretty much that I write on the side is all open source. You all can look at it. Most of it's on VIPM. This will be on VIPM once I clean up some more things. If you wanted to go to the Summer of LabVIEW repo, this has a link back to the server. It's also got a VIPC that has the current full version of all of those dependent libraries. But there's a lot of documentation on this repo, shows how controller registration works. So here's an example of, I just want to serve some things from a folder on disk. So you just configure a path. This one's doing it based on where the executable is, and then a relative folder to that, setting that as the path for this built-in file controller mechanism, registering that, start the server, and now that server will serve any files from that path. So each of the individual configurations are, I would hope, really straightforward and simple to do, and you can get really complex behaviors just by composing all of these individual steps. So it goes into documenting everything. Here's the processing flow diagram that we looked at already. This is the actual, well, we'll look at this in real code because that's kind of tiny. This is the actual request processing implementation. So there's a lot of information on the repository if you go there, and I'll have a link at the end, QR code. Talks about the debugging features that are built in that we looked at. So that's the repository for the server itself with all that documentation. The server code has examples of all of the different components in the web server. So this is how you would enable CSRF features. You need to use sessions. Some form of session implementation needs to be available for it to store the tokens in and some of the keys that are used for that. Again, everything in here is extensible. This is the built-in implementation of a session handler, but you could write your own session handler that backs up sessions in a database, for instance, instead of saving them to disk. So there's a lot of examples of how to accomplish the different things in here. That one doesn't look like it has much. So testing file uploads. This one just has to register the handler code that will respond to the page request, and you start the server. And then this is just here to keep running, to keep the server running until we want to shut the server down. And then if we look at that controller, so this is doing just a very pared down version of what the Summer of LabVIEW site is doing, demonstrating just if I want to do file uploads, how can you do that? So you can see what the original file name. So there's a whole bunch of fields that get attached. Basically, the whole idea of this web server is you have access to everything that comes in the web request. A lot of the common use cases are wrapped with easy to use sub-VI calls, but pretty much everything is accessible. If you really wanted to, you could get access to the underlying TCP stream for some shenanery. Anything else? Eventually, WebSockets will be a first-class supported feature for doing WebSocket connection upgrades. I still got to finish some of that WebSocket stuff, as I mentioned earlier. Okay, so if you want to pull your phones out, this is where you can find a lot of what we just looked at. So again, my moniker that I do all my open source development on is Illuminated G. You can find me on GitHub. The Summer of LabVIEW repository is the one that's on the left. It's got that VIPC file, which would give you everything until I get it all released on VIPM. And if you want to look up anything I do have on VIPM, it's vipm.io/profile/Derrick B. I've got a bunch of communication stuff. I've got some UI stuff. Eventually I'll have things like virtual terminal emulators based on those stream implementations. So I'm really looking forward to NI finishing their SSH implementation and getting that rolled out. Couple of shameless plugs. So I am a couple of other side projects, because I have too many. So PicoG is one of the projects that I helped get started, and we would love to have some more help with that to get some more of that functionality completed. That is basically using the output of GWeb to generate something that can be run on microcontrollers and embedded Linux computers. So if you do C++ programming, we would love to talk to you. We write wrappers in GWeb to expose some of the functionality that's available. And then we've got a desktop application that does all this. It's kind of like a mini Max for managing your embedded targets. And that's all written in LabVIEW. And then also gcentral. So we've got the website, gcentral.org. We're working on a new version. I keep getting busy with all these extra side projects. So we would also love some help with that. If you are experienced with PHP development at all, or JavaScript development, we could certainly use some help from that. The whole idea there is it's going to be a repository of LabVIEW code that's available. So whether it's links to GitHub repositories, links to forum posts that have links to code, links to VI packages, NI packages, and maybe eventually someday creating a public NIPM repository. Okay. Crazy fire hose. One thing I'm certainly interested in is anybody that does Active Framework or DQMH, figuring out what best practices are for integrating that kind of code with a server like this. And of course, anybody that's interested in using more extensible web server development in LabVIEW, would love to hear some of the application ideas you might have and if there's any features we need to use. Once I get the WebSocket upgrades and the caching working, it's feature complete for me. But of course, there's plenty of stuff that could be added to it and documented better or anything like that. So, Alan.
Derek, I live up the road. Give me a call. We'll talk.
Okay.
This is a little bit off topic, but you mentioned you referred to SQLite, and I assume you're not talking about the Citadel database. And I'm just wondering which I use, but I would like to get away from. So, what are there tools that basically replicate that functionality that are readily available?
So this is the library I'm using that I just wrap. So this is an embedded server. It is a file-based server that just works through a DLL wrapper. I'm not familiar with the Citadel database, so I wouldn't be able to tell you anything about that. But this is what I've used. It's not meant for really large applications, but for small to medium-sized applications, it works fantastic. You can have multiple access to it. And if there's anybody else that knows what he was talking about and wants to answer, that would be cool as well. I guess we did not look at any of my actual database code. Oh, challenges are a little funky. Okay, so yeah, so I've got entities. These are the actual just data container classes, which I just wrapped a single cluster to make it easy for the actual database instance to get all the fields and populate it all at once. Then the actual database implementations look like this. So that is the user. So let's look at the user database. So for instance, here's the load by identifier, pulling out the SQLite instance, doing the query to get all the fields. So this is all handwritten. Someday it'd be really cool if there was a way to do some scripting or code generation to do all of this, because it's pretty robotic based on the fields that are in the class. And then just filling them in and creating a class instance populated with that data. And then if we needed to update one, setting up the query using parameter binding, just so we get all of the escaping and everything built in to prevent SQL injections and all of that, using best practices, doing the actual submission, making sure it inserted properly and got the ID. So this is, it's relatively straightforward flow for doing the database stuff. Yeah. Bless you.
Hey, Derek, that's awesome. Have you implemented this on a real-time target?
I have not used it on a real-time target. It uses everything that's supported on a real-time target. It would run. It does a lot of stuff in the background, so VI prioritization would probably become important. There are, right now it does kind of dynamically allocate for each request that comes in. That's one of the things I'm looking at optimizing. I initially wrote it so that you could continue to register services and handlers as the application runs, or unregister handlers. I thought I might need that. I think it'd probably just be good to, once you start the server, however you have it configured is what it is, and then we can optimize a lot of stuff out. Pre-allocate some things, maybe have like 10 or 100 handlers, which would all make it more friendly with RT. But yeah, the idea is that this is just using all, even for the HTTPS stuff, it's using all LabVIEW primitives and built-in stuff. So anything 2020 and up, and it will run on.
Awesome.
Any other questions?
Got everybody ready for lunch.
All right. Thanks very much, Derrick.